So we're going to have a look at some more questions from the 2014 University Calc 1 uni paper. So here we have a sine derivative and then we have a trapezoidal rule. So question 24, we are asked what is the derivative of this function with respect to x? Well, this is a chain rule. So first we'll start by saying it is known that if y is sine of x, then y prime is cosine of x. You could say sine hyperbolic of x, cosine hyperbolic of x. Sine and cosine are just names given to these. So if we do this as a chain rule, the inside function is u is equal to x cubed plus 3x plus 2. The outside function is y equals sine of u. So the derivative of the inside function, u prime, is 3x squared plus 3. The derivative of the outside function, y, is cosine of u. Now we have to multiply these together. So this implies that the derivative of our question, so this is a rule here, the derivative in our case, y prime, is going to be 3x squared plus 3 times cosine of u. Now we need to back substitute this u in here. So this gives us y prime is equal to 3x squared plus 3 times cosine of x cubed plus 3x plus 2. So pretty straightforward derivative here. Now we have to identify which of these is the answer. Well, it's definitely not B, it's definitely not C, it's definitely not A, and it is D. So it's possible in this question that it could be none of them. You could get a question like this where the answer is so very similar to the 4, but actually it's none of them, and then it would be none. In this case, it's D, though. Now let's have a look at question 25. So here we have a numerical method. We're going to be using trapezoidal rule. Now the trapezoidal rule that we're given here, we are given not in the question, but on another page. A version of the trapezoidal rule is provided, which is b minus a over 2n times f of a plus f of b plus 2 times the sum of the intermediate terms. So this is x1 up to fxn minus 1. So this is our trapezoidal rule, and it's not actually area is equal to, it's area is approximately, because this is a numerical method. This is finding an approximate solution for something. So what is the trapezoidal rule approximation for the function f of x equals sine of x over the interval 0 to pi with n equals 4 trapezoids each of width pi on 4? Okay, so if n is 4, we're going to have 5 values. We're going to do a table of values for this, and then plug values from our table of values into formula. 1, 2, 3, 4, 5. We'll need 5 of these. These will be the y values, these will be the x values. So if we're moving in iterations of pi on 4 along the x-axis, we'll have 0, pi on 4, 2 pi on 4, 3 pi on 4, and then 4 pi on 4. Now obviously some of these simplify. I'm just going to leave them like this because that's fine. And then the y evaluations will be sine 0, sine pi on 4, sine 2 pi on 4, sine 3 pi on 4, and then sine 4 pi on 4. Now again, obviously, some of these are cancelable, but we're not going to worry about that for the time being. So now we need to do our trapezoidal rule formula. So we are told A is equal to B minus A. So B is 4 pi on 4, that's pi. A is 0, divided by 2 times n. Well, n is 4, so this is 8. So we have pi minus 0 over 8 times f of A is going to be sine theta. So this will be the starting y value. So sine theta, which is sine of 0, plus sine of b, which is sine of 4 pi on 4, which is sine of pi. Sine of pi. And then we need to add 2 times all of the other sine evaluations. So this is sine of pi on 4 plus sine of 2 pi on 4, which is sine of pi on 2, plus sine of 3 pi on 4. And this has double brackets at the end closing this. Now, this answer, there is a sort of trick way to do this once you're at this point. This whole thing can just go into your calculator, and then you can numerically evaluate A, B, C, and D, and you can just pick the one that it is, and if it's none of those, then it's none of the above. So this is one of the easier ways to do this, but we'll simplify this expression manually a little more before we do this, because you may get a long answer question of this, and it might say, show that the area is this particular value, and then using the calculator would be considered inappropriate in that case. So we have pi on 8 times sine of 0, which is 0. Sine of pi is also 0. So then we have 2 times sine of pi on 4. Well, sine of pi on 4 we know is 1 on root 2 for our special triangles, plus sine of pi on 2, we know that's 1, plus sine of 3 pi on 4, we know that that's also 1 on root 2, because the sine function does this. If this is pi on 4, this is 3 pi on 4, these actually have the same y value. So now we can add everything together here. So this is going to give us, let's see, pi on 8 times, we'll add everything in the middle here, we'll multiply this 1 by root 2 on root 2, so we'll get 2 plus root 2, 2 times 2 plus root 2 over root 2, multiply this, cancel this 2 with this 8, so this becomes a 4, this will give us pi on 4 multiplied by 2 plus the square root of 2 over the square root of 2. Now we can cancel some square root of 2's here. So this becomes, so this is not an implication, this is an equals, this is just equal to pi on 4 multiplied by root 2 plus 1. And so now we can numerically approximate this. So let's see what our calculator gives us here. So we have pi on 4 multiplied by the square root of 2 plus 1. So this gives me 1.8961, 1.8961 dot 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 dot. And we know that this is the area under a part of the sine curve approximately. Right, so we know that we should get a value that's approximately the area under one part of the sine curve. If you go from 0 to pi on 2, so the integral of sine from 0 to pi on 2 is negative cosine from 0 to pi on 2. That ends up being negative cosine of pi on 2 plus cosine of 0. Cosine of pi on 2 is 0. Cosine of 0 is 1. So you end up finding that half of this area is 1, which means the whole area should be about 2. So we should get an answer that's about 2. 1.8961 is about 2. And in fact, because this has a pi on 4 in it, this is not any of the answers here. The actual answer is pi on 4 times root 2 plus 1. And so the correct answer in this case is actually E, which is none of the above. This is a sort of trick question, because they put a whole bunch of answers, B, but one of which looks incredibly similar to the correct answer. A whole bunch of them do. Right? C does as well, because you've got a pi on 4 And so if you evaluate some of these, but pi on 4, of course, is like sort of 3/4. So when you look at answers like C, that's 1/2 times root 2 plus 1. That's going to give you a very close answer. When you look at D, you can factor a 4 out. That's 3/4 times a half plus root 2. That's going to be very similar as well, right? These will be very similar numbers. They're not the exact numbers that we get from using this iteration of trapezoid rule, the version of trapezoid rule that we're provided, but they are very close. This is a common gimmick associated with some of these questions. You can be given a bunch of answers, all of which sort of look correct, but aren't. The difficulty here is actually fighting the urge to select a close answer, because students always go, oh, you know, there's a bunch of answers. I should not select none of the above. People tend to think that none of the above is not going to be one of the answers in the questions. It can be, and it sometimes will be. It's not just there if the lecturers make a mistake. That's part of the reason it's there, because when you get to these level content, the lecturers sometimes make errors when they're writing the exams in order to cover themselves. They put a none of the above, or too difficult to complicate, or, too difficult to calculate, something like that. In this case, it actually is none of the above.